natural logarithms. This section should be pretty seamless because it's just a review of everything we've talked about to this point. So you're not expected to have mastered all of it, but you should be familiar with all of it. The basic idea, if I ask you for log base e of m, we can call that n. Just say log base e of m is n. That's the same thing as writing ln of m is n. Log base e is just natural log. That is what a natural log is. That's what natural log. The nice part in all of this, all the rules are the same. It is a logarithm. So all the rules we've been going over for logarithms apply because it is a logarithm. So here, if we want to write each expression as a single natural logarithm, this is just condensing logarithms, which is again something we have done already. Part A, go through and use the power rule. We get ln of 8 minus ln of x cubed. And we get ln of 8 because the 3 out here, by the power rule, moves inside as an exponent. So 2 to the third, and 2 to the third is 8. So again, the power rule, not something you're expected to have mastered at this point, but it is something you're expected to recognize at this point. So to finish part A, we use the quotient property. This becomes ln of 8 over x cubed. And we're finished. We have rewritten it in terms of just one single logarithm. In part B, we start by using the power rule again, or the power property. ln 9 plus ln 8. We moved this 2 inside as an exponent. Then we use the product property. Those combine to just be ln 72. Part C. Go through and use the power property. We get ln x to the 20th plus ln y to the 5th minus ln z squared. So when you're doing this, the order in which you should try it, always look to see if the power property can be used first. And if it can, and if it can be used, use it. Then, if you have multiple additions and subtractions going on, work your way from left to right. So let's start with the product property. We get ln of x to the 20th, y to the 5th, minus ln z squared. Because this is addition, this must be multiplication. Now we have subtraction, which tells us this is the quotient property. So we have ln of x to the 20th, y to the 5th, all over z squared. And we are then finished with part C. So we want to rewrite these in exponential form. We should all remember how to rewrite a logarithmic equation in an exponential form. So that's the first thing you have to remember. And the second thing you have to remember is that when you do that process of rewriting it, you have to know what the base is. So you have to remember that the base of the natural log is e. So part A in exponential form is e to the 5th equals x. So that is, in fact, the most difficult part of the problem. Now that we have the fact that e to the 5th equals x written down, you take your calculator and you put in e to the 5th And the calculator will inform you that that is in fact 148.4132. You get E by pushing second division sign. Solving part B, rewrite it in exponential form. E cubed equals 6x plus 1. So then E cubed minus 1 equals 6x. So E cubed minus 1 all over 6 equals x. You put that in the calculator, and you should get 3.1809. Rewrite it in exponential form. We get e to the sixth is 2x plus 1 squared. Once we have it rewritten in exponential form like this, to begin solving for x, I'm going to take the square root of both sides, which is going to give me plus or minus 20.0855 equals 2x plus 1, meaning I have to write two different equations. 20.0855 equals 2x plus 1, or negative 20.0855 equals 2x plus 1. You have those two equations, you just need to solve both of them. Subtract 1 from each side, then divide by 2 on each side. So in the first part, we get that x is 9.5428, or we could get that x is negative 10.548. What do you suppose we should do at this point? Okay, both of these answers do work, but you do need to check. Make sure if you get multiple answers, and it's even good practice if you get just the one answer, make sure you're checking your answers to ensure that they work. And in this case, both of those choices do in fact work. So we solved logarithmic equations by rewriting them in exponential form. Now we're going to solve exponential equations by rewriting them in logarithmic form. So part A, we would rewrite that as log base e of 24 equals x plus 3. But log base e of 24 is just natural log ln 24 equals x plus 3. So do ln 24 minus 3. That equals x, so that should be 0.1781. Part B. In part B, I would begin by dividing each side by 5, and then rewriting it in logarithmic form. ln 9 is negative 3x. Divide each side by negative 3, you should get that x is negative 0.7324. The first thing we should do in part C is add 8 to both sides. Then we should divide by 2 on both sides. At that point, we can rewrite it as a logarithm. ln 19 is 5x. Divide each side by 5, and we get that x is 0.5 0.889. This is a word problem that had a lot of words to ask you to do something pretty simple. A lot of words, but here's a formula, and this value right here is a percentage. What is t if that percentage is 30%? So you just plug in 0.3 right here. So t equals ln of 0.3 divided by negative 0.693 times 5700, at which point it is just another exercise in plugging things in the calculator appropriately. You round to the nearest whole year, you get 9,903 years old.